so that's the contribution from one tiny piece, and now what I'm going to do is I'm going to add up the contribution to the electric field from all the points around the ring. So of course I do that by integration, so the total electric field will be given by a sum over all of these pieces. In other words, I'm going to integrate phi all the way around in a circle from 0 to 2 pi of q over 2 pi all over 4 pi epsilon naught L squared plus A squared to the 3 over 2 L minus A sine phi minus A cos phi d phi. Now we've got three integrals to do, one for each of the components. So I get E total is given by Q over 2 pi over 4 pi epsilon naught. Notice all of this stuff I'm writing down here is completely independent of phi. I can just bring it all out the front of the integration. And now I've got to integrate each of these three components. And what I will end up with is L phi from 0 to 2 pi. I'm doing the integral d phi just of L and I get a phi. Now I've got cos phi goes to minus sine phi, so I got A cos phi from 0 and 2 pi. And then minus A sine phi between 0 and 2 pi is the integral of minus cos phi. Sine phi differentiates to cos phi. Okay, and if I then evaluate those, well, cos phi at 0 and 2 pi is the same, and so these will give you 0 when you put the integration limits in, and similarly for this guy, and so I'm just left with q over 2 pi over 4 pi epsilon naught L squared plus A squared to the 3 over 2 L times 2 pi 0, 0. And of course if I want I can bring this factor of L 2 pi out here, cancelling that 2 pi, and just leave myself with the unit vector for the vector piece.